integrity domain. All these things matters to the cyber security. Now, we all know something about public key cryptography. Yes? Okay. So, there is something called as digital certificate and all. Is it right? So, what is the digital certificate? So, it is trying to bind the public key with the identity of the person through a trusted party. There is something called a certification authority who is going to tell, yes, this so-and-so person is Ravi and this is the public key of this person. This is what they are going to sign and give it. So otherwise, it is very difficult if someone says, this is my public key, I cannot accept that particular unless it comes from this thing. So that is one of the limitation in case of public key cryptography. So the two approaches which are used to resolve that particular trust problem in public key cryptography, one is web of trust, which is used in a pretty good privacy solution, PGP. So how it is done is, suppose if someone, let us say Madhavi is very close to me. I know Madhavi very well. If Madhavi says, okay, so some other person's name she refers and says that this is a public key of some other person, then I accept anything coming through the Madhavi. So this is called as a web of trust. But what happens in this particular case is, you can only limit to the small systems. You cannot think about an enterprise or the building this kind of trust. Okay, that's the limitation of this. The other approach what is used is, that is nothing but the certification authority which is used in all our systems, whether you talk about your SSL or IPsec or any of these online services, we try to make use of the certification authority. So there is an entity who is a trusted party who is going to issue the digital certificate. So we don't depend on the people and their trust, it is scalable and there are clear procedures when to revoke the things and all. But the problem is, if the CA is compromised, is it right? That the system will come the failure. Is it right? This is a single point of failure. CA is a single point of failure. So in the past, there are a lot of breaches happened with the well-known CAs like VeriSign, TrustWave and DigiNotar. So these kind of issues happened. So one of the proposal possibilities like blockchain-based PK, public key cryptography in public key infrastructure setup, like instead of depending on a single CA kind of thing, why don't we maintain this particular public key infrastructure, digital certificate, everything on a blockchain, where the single point of failure and all will not be there. So that's the thing. So you can just read, I'll share the slides actually. So if PK is maintained on a blockchain, single computer is replaced by a group of connected computers, making it more robust and trustworthy. And another thing is, like if you talk about a cloud, everyone talk about a cloud, right? So instead of owning some kind of licenses or resources, you're trying to depend on a cloud service provider, is it right? But the problem is, how do you ensure that the service provider is using your data, okay, in whatever he tries to claim in SLA and other things like that? Is there any way where you can try to prove that, whether he's trying to use it properly or maybe he's trying some kind of backdoors and other things like that? So one possibility is we can think about some kind of blockchain-based logging and integrity management system. So where we can try to develop a solution, technology we can try to enable for clouds and all, so which can try to help us to check the integrity, audit that particular environment, and also like suppose in case some breach and all happens. So forensic analysts should be able to identify what happens, right? For that there should be a track of the each and every activity. So that also can be assisted to these kind of the blockchain. And then we talk about IoT now, is it right? So we talk a lot about IoT and we know that these are now the devices are going to work along with us, is it right? Yes, in solving our day-to-day activities, they are going to help us. So we have heterogeneity in the devices, they are very small and these devices have multiple attack surfaces. They are available, see, there is no physical security, you cannot protect them. So and there is context specific and also these devices don't follow any standards for security and privacy mechanisms. So in this particular case, so we need to move away from the centralized approach. Whenever you want to provide the security and all, for IoT we need to move away from this thing. And we have to explore these fundamental principles of IoT, peer-to-peer messaging, distributed data and file sharing, and autonomous device coordination. Okay, so this blockchain technology with these kind of fundamental functions will help you to ensure these kind of concerns in IoT. So we can have new device registration, authenticating users and devices to the IoT, and secure messaging across the device. All these things can be enabled through by maintaining a blockchain in the IoT environment. So like it can help you to tracking billions of connected devices and then enable the processing of transactions and coordination between these devices. And then decentralized approach will eliminate the central points of failure, and it's more resilient ecosystem for device to function. Okay, so also the cryptographic algorithms and all make consumer data more private. Okay. So similarly, we talk about domain name service and all. Yes. So here again, this has got denial of service attack can be launched. So the distributed denial, so this kind, again we can have DNS. DNSSEC is there existing, but it provides only authentication, but it cannot protect from DOS or DDoS. So for that reason, we can think about blockchain-based DNS alternatives. Okay. So already there are efforts in some of called the Namecoin and Blockstack. Okay, for maintaining the decentralized, secure, and human-friendly naming systems. Okay, right. So because see the DNS server itself can be compromised, service can be compromised. Okay. Another problem which we faced is like the updates from the antivirus or anti-malware solutions. So now one approach people are using is the update mechanism, let it come through a blockchain distributed environment. So suppose if an updated server comes to a halt or anything like that, and also the performance, the speed at which the updates and all to happen can be improved through the blockchain-based antivirus. One effort is already going on, that is a BitAV. And another effort is, suppose whenever your firewall receives a file, Windows portable executable file or anything like that. So in that particular case, actually you can distribute to the other nodes and take their advice, ask them to give whether it is a malicious entity or not through a blockchain. So that's how we can have an integrity of the details given from every node in the blockchain. Yeah. So these are some more things like protection from the supply chain attacks, because you are trying to maintain the complete the details of all the supply chains, transactions, everything. So it's a promising technology. Okay, so I think I have done some justice in making you understand what is blockchain and advantages. So definitely it has a lot of relevance in the cybersecurity domain, and also plenty of applications in governance, healthcare, in all these areas. But the thing is security for blockchain. That is one thing which we need to look at it. So just the way in which the WannaCry and all have come, once you heavily use the blockchain, there will be so many people trying to enter into the blockchain. Is it right? So now we should try to look in that direction. Then standards should be evolved. Already ISO is coming out with a standard for blockchain. And also India, also Bureau of Indian Standards is looking for the blockchain standards. And when you maintain at all the nodes and you need to sync up the blockchain ledger across all the nodes, bandwidth, computational power, storage, all these matter. Is it right? From a central location, now you are saying that at every node I am going to maintain the ledger. And also choosing for right application. It's not that, okay, everywhere you can use the blockchain. That's not the case. You have to look at the relevance and then try to use the advantage of that. Okay. So this is something. So maybe I'll take 2 minutes. So this is something about the efforts which we do at CDAC. So our team basically looks at R&D in endpoint security. So we develop a lot of the solutions that. So we also try to work in security auditing services. So we try to audit the various websites, networks, mobile applications and all. It's one of the certain empaneled agency. And we keep conducting education and training programs, awareness generation. We also do national level awareness initiative. So some solutions, actually I just gave some links, you can download these products. That's the idea. Just go to CDAC, www.cdac.in/anyone, you can get it, mKavach or USB kind of thing. So minister, actually our honorable minister of the central minister has recently launched it for the citizens to download these products in the month of February last year. So like CDAC is always keen to associate with industry, R&D, academia and associate in various areas like developing new products or scale up the developed solutions or conduct some training programs on wider scale, and also like anything customizing based solutions. See, one thing which I would like to tell is there is something which CDAC has started recently, that is something called Diploma in Modern Software Development Essentials. So this is something like I am leaving some brochures outside, you can have a look at it. So they are looking at the fundamentals which are required for a software engineer to work in the industry along with the latest technologies. These are targeted in this particular thing. So and also giving emphasis on cyber security in terms of secure coding practices.